Q5703-1. Loss of tail rotor effectiveness, LTE, is caused by A. A main rotor disk vortex causes the tail rotor to operate in an extremely turbulent environment. B. The failure of the power drive portion of the tail rotor disk, resulting in a complete loss of ant torque. C. An aerodynamic interaction between the main rotor and tail rotor and not caused from a mechanical failure. The correct answer is C. Loss of tail rotor effectiveness, LTE, is caused by an aerodynamic interaction between the main rotor and tail rotor and is not caused by a mechanical failure. LTE occurs when certain flight conditions or maneuvers result in a loss or reduction of the tail rotor's effectiveness in countering the torque produced by the main rotor. It is primarily an aerodynamic phenomenon rather than a mechanical failure. 5704. When operating at high forward airspeed, retreating blade stall is more likely to occur under conditions of A. Low gross weight, high density altitude, smooth air. B. High gross weight, low density altitude, and smooth air. C. High gross weight, high density altitude, and turbulent air. The correct answer is C. Retreating blade stall is a condition that occurs when the retreating blade of a helicopter rotor system reaches a critical angle of attack and loses lift. This can happen when the helicopter is flying at high forward airspeed, because the retreating blade is moving through the air more slowly than the advancing blade. The likelihood of retreating blade stall is increased by high gross weight. A heavier helicopter requires more lift, which means that the blades must be pitched at a higher angle of attack. This makes it more likely that the retreating blade will reach a critical angle of attack and stall. High density altitude. The air is less dense at high altitudes, which means that the blades must be pitched at a higher angle of attack to generate the same amount of lift. This makes it more likely that the retreating blade will reach a critical angle of attack and stall. Turbulent air. Turbulent air can cause the blades to be buffeted, which can lead to a loss of lift. This makes it more likely that the retreating blade will reach a critical angle of attack and stall. 5705. What are the major indications of an incipient retreating blade stall situation in order of occurrence? A. Low-frequency vibration, pitch up of the nose, and a roll in the direction of the retreating blade. B. Slow pitch up of the nose, high-frequency vibration, and a tendency for the helicopter to roll. C. Slow pitch up of the nose, tendency for the helicopter to roll, followed by a medium-frequency vibration. The correct answer is A. Retreating blade stall is a condition that occurs when the blades on the retreating side of the helicopter's rotor system are moving through the air too slowly to generate enough lift. This can happen when the helicopter is flying at high speeds, carrying a heavy load, or in turbulent air. The major indications of an incipient retreating blade stall situation are low-frequency vibration. This is caused by the blades of the rotor system fluttering as they stall. Pitch up of the nose. This is caused by the helicopter's tendency to nose up in an attempt to maintain lift. Roll in the direction of the retreating blade. This is caused by the helicopter's imbalance in lift as the retreating blade stalls. If a pilot notices any of these indications, they should take immediate action to recover from the situation. The most important step is to reduce the helicopter's airspeed. This can be done by lowering the collective pitch or reducing the throttle. The pilot may also need to apply opposite cyclic control to prevent the helicopter from rolling. If the pilot does not take action to recover from a retreating blade stall, the helicopter may enter a full blade stall, which can lead to a loss of control and a crash. 5706. How should a pilot react at the onset of retreating blade stall? A. Reduce collective pitch, rotor RPM, and forward airspeed. B. Reduce collective pitch, increase rotor RPM, and reduce forward airspeed. C. Increase collective pitch, reduce rotor RPM, and reduce forward airspeed. The correct answer is B. When a helicopter is experiencing a retreating blade stall, the pilot should take the following steps to recover. Reduce collective pitch. This will reduce the angle of attack of the rotor blades and help to prevent them from stalling further. Increase rotor RPM. This will increase the lift generated by the rotor blades and help to stabilize the helicopter. Reduce forward airspeed. This will also help to reduce the angle of attack of the rotor blades and prevent them from stalling further. If the pilot takes these steps quickly and smoothly, the helicopter should recover from the retreating blade stall without incident. However, if the pilot does not take action, the helicopter may enter a full blade stall, which can lead to a loss of control and a crash. Here is some additional information about recovering from a retreating blade stall. The pilot should not increase collective pitch during a retreating blade stall. This will increase the angle of attack of the rotor blades and make the stall worse. The pilot should not reduce forward airspeed too quickly. This can cause the helicopter to enter an aerodynamic stall, which is a different and more dangerous condition. The pilot should maintain a smooth and controlled approach to the ground during recovery. This will help to prevent the helicopter from rolling or pitching excessively. Retreating blade stall is a serious condition, but it can be successfully recovered from if the pilot takes the correct steps. By understanding the indications of a retreating blade stall and knowing how to recover from it, pilots can help to ensure the safety of their passengers and crew. 5707. The most power will be required to hover over which surface? A. High grass. B. Concrete ramp. C. Rough/uneven ground. The correct answer is A. Hovering over high grass requires the helicopter to generate more lift to counteract the added aerodynamic drag from the tall grass. The grass creates more resistance to the airflow, which reduces the efficiency of the rotor system, resulting in a higher power requirement to maintain a stable hover.